Okay, here's a wild thought. What if you woke up tomorrow and the Earth was twice as big? I know, it sounds like something straight out of a sci-fi movie, but the consequences would be very, very real. So in this explainer, we're going to break down exactly what would happen to you, to our planet, and to life itself.
So let's really set the scene here. You wake up, you look outside, and the Earth's radius has just doubled. Everything looks kind of the same, just way bigger. So, what actually changes? Well, the answer is pretty much everything. And it starts with the one force you can't escape.
Okay, so before we dive headfirst into the chaos, we need to set one ground rule for our little thought experiment. We're going to assume the planet's density stays exactly the same. Now, physics tells us that if you double the radius while keeping the density constant, well, what do you think happens to gravity? The answer is simple, and honestly, it's terrifying. It doubles.
And that, right there, brings us to our first, most immediate problem: the crushing new reality of what scientists call 2G gravity.
A 2 times increase in gravity means you would feel twice as heavy. Every single moment of every single day would feel like you're carrying a person of your exact same weight on your back. Just think about that. Trying to get out of bed in the morning would be this monumental struggle.
So under all this immense pressure, what part of your body do you think would give out first? Your first guess might be your bones, right? But you'd actually be wrong. Turns out, human bones are incredibly strong. Your muscles, though, they're a completely different story. Yeah, check this out. Research shows your bones could probably withstand up to 10 times Earth's gravity before they'd just break under their own weight. But your muscles, they would give out way, way sooner, somewhere around the 5G mark. On our new 2G Earth, just the act of standing up would become a massive athletic feat. And you know what? We can actually put a number on this human limit. When a world-class strongman walked just 5 steps carrying a 649-kilogram log, that's almost 1,500 pounds, the effective force on his body was the same as walking on a planet with 4.6 times normal gravity. So what that tells us is that for even the strongest people on Earth, anything beyond 5G makes basic movement pretty much impossible. Okay, so we've established that walking around would be a nightmare. But what about the bigger picture? Let's stop looking at our feet for a second and look up at the sky and see how a supersized Earth would change our days, our years, and our whole view of the cosmos. So, here's a surprise. Our trip around the sun, it would be almost completely unaffected. A year would still be a year. Why? Because our orbit is all about the sun's mass, not Earth's. But the length of a day, that's a total cosmic lottery. There's just no direct link between a planet's mass and how fast it spins. I mean, look at Venus. It's about our size, and its day lasts for 243 of our days. Then you've got Jupiter, the absolute giant of our solar system, and it whips around in just under 10 hours. And this unpredictable spin leads to a more subtle, but kind of profound loss. Our new, stronger gravity would pull the moon into a totally different orbit. And that means that beautiful, perfect cosmic coincidence where the moon perfectly blocks out the sun, giving us a total solar eclipse, that would be gone forever. A truly special feature of our world just erased. All right, let's pull our focus from the sky and look back down at the very ground beneath our feet. Because while we've been busy worrying about eclipses, a really violent geological chain reaction has been set in motion. It's this devastating ripple effect you see. It starts with more mass. More mass means more radioactive elements deep inside the planet, making the core much, much hotter. This supercharges the convection currents in the mantle, which in turn leads to a thinner crust and a massive spike in volcanic activity. And what do all those new volcanoes do? They pump incredible amounts of carbon dioxide into the atmosphere, triggering a powerful greenhouse effect. This could kick off something called a runaway greenhouse effect. And folks, this is the point of no return. It's a vicious feedback loop where the planet gets so hot that the oceans start to boil. That puts even more heat-trapping water vapor into the atmosphere, which makes the planet even hotter. And you see where this is going. Eventually, the planet just can't cool down at all. It's what we think happened to Venus, turning it into the scorching hot world it is today. So yeah, humanity, we're probably not surviving this. But what if life had started on this high-gravity, high-pressure world from the get-go? What would it even look like? How would evolution adapt to conditions this extreme? The entire blueprint for life would be rewritten by gravity.
Trees couldn't grow tall, they'd have to be short and incredibly stout just to hold up their own weight. Animals that leap and bound around, like kangaroos or deer, they just couldn't exist. Even the landscape itself would change, with mountains slumping under their own mass, becoming shorter and wider. And hey, while a thicker atmosphere might make it easier to fly, the landing in 2G gravity would be, well, lethal. The one safe haven? The oceans. The buoyancy of the water would counteract gravity, making it the most likely place for complex life to thrive.
And, this isn't just some fun thought experiment. Planets like this, which we call super-Earths, are very real. We found hundreds of them out there. This chart actually shows the distribution of surface gravity on the exoplanets where we have enough data to figure it out.
Notice something really interesting here? Most of these planets have a surface gravity of less than 5G. Does that number ring a bell? It should. It's right around that upper limit of what a highly trained human might just be able to handle. It tells us that while a 2G world would be an absolute nightmare, there might be a surprising number of real planets out there that humans could just barely walk on. Ultimately, this whole exercise really just shows how incredibly fine-tuned our own planet is for the life that calls it home. The gravity, the geology, the atmosphere, it's all part of this unbelievably delicate balance. It really makes you wonder, as we search the stars for another Earth, are we looking for a common type of world, or are we actually searching for a cosmic miracle?